Hi, in this video, we are going to look at some practice problems for JEE Advanced. So this is the first question. Here we have listed down four sets, S1, S2, S3, S4. The conditions are given for each of these sets, and the question is basically finding the cardinality of each of these sets. So we have to find the number of elements in each of these sets, right? So let's look at set 1, for example. Set 1 is a ordered set of three elements ijk such that each of ijk belong to the set of numbers from 1 to 10, right? So how many ways can we select an ordered triplet of three elements ijk where every element belongs to the set 1 to 10? So obviously the order has to be taken into account here. So we have to say that for the first element, how many choices are there? There are 10 choices here, right? And similarly, for the second element also, there will be 10 choices. And for the third element also, there will be 10 choices. So the number of ways in which we can make ordered triplets here would be simply 10 into 10 into 10. So the cardinality of S1 or NS1 is equal to 1000. So that is the first part of the problem. We get that NS1 is 1000, and that is fairly straightforward. Now we have to look at the others. So before we do S2, which is slightly more complicated, we'll look at S3 and S4 and try to understand what happens here. So let's think of the cardinality of S3. So here, what do we have to do? We have to select a set of four elements, ordered quadruplet basically, of I, J, K, L, such that I is greater than equal to 1. And there is a distinct order here. I is less than J, is less than K, is less than L. And all of those four elements I, J, K, L will belong to the set NS1, right? So basically the question is asking us to form a quadruplet. So select four elements from the set 1 to 10, and once you select those elements, you have to make sure that they are in the proper order, right? So if you think of 1, 2, 3 till 10, if you select four different integers from here, four different integers from this set. Obviously, that can be done in how many ways? 10C4 ways, right? And as soon as you have selected any four different integers, obviously those integers are different from each other, so they will follow ascending or descending order, right? So you can name the smallest one of them as I, and J is the second smallest, K is the second largest, and L is the largest, right? So for each of these 10C4 ways, you get one ordered quadruplet, right? Because once you have selected four, you can always form a quadruplet, right? So this question is also pretty easy. NS3 is simply 10C4, right? Now try to understand what is the difference between solving S3 and S4. Think of what is S4. Here also we have to select four different elements. This is a quadruplet, but now there is no restriction on IJKL, right? There is no restriction on IJKL, as in it doesn't have to be in any particular order of ascending or descending, right? I could be bigger than J, K could be bigger than L, and so on, right? So again, this time we do the selection in 10C4 ways. So we have selected four elements, but now notice that we can arrange them in any particular order, right? The four integers that we have selected, we can arrange in 4 factorial ways. So you will get 10C4 times 4 factorial will give you the different orderings of a single selection, right? So basically, since we have an ordered quadruplet, we need to care about the order of the integers inside it. In the previous problem, the order was fixed because we had to put it in ascending order, right? But this time we have 10C4 times 4 factorial because the order has to be random. It can be any order, right? So NS4 basically becomes 10C4 times 4 factorial. And now we come down to S2. So we have to calculate this S2, the number of elements in this S2 set, and that I will do on the next screen. So S2 is basically an ordered pair IJ where the conditions that are satisfied by I and j are 1 is less than equal to I, 1 is less than equal to I less than j plus 2, and j plus 2 is less than equal to 10, right? And both I and j belong to the set 1, 2, 10, right? So looking at these conditions, we can say immediately I is greater than equal to 1 and j is less than equal to 8, right? These are obvious conditions that we get, right? So now what we will do is we'll try to satisfy this middle inequality. This middle inequality has to be true. So let's take cases. Since I is greater than equal to 1, what is the situation when I is equal to 1? If I is equal to 1, j can be anything from, think about what j can be. We have to make sure that I satisfies j plus 2. So obviously j can be anything, right? It can be 1, it can be 2, it can be anything till 8, right? Because always this inequality is satisfied. So j can take values 1, 2, 3 till 8. So there are 8 ways. 8 ways in this case when I is equal to 1, right? When I is equal to 2, again we have to try to satisfy this inequality. I is less than j plus 2. So now again, j can take the value 1 also. It can take the value 2 also. Because if you do 1, 2 is less than 3. So that is correct. And obviously it can take all the values here, 1 to 8. So again, 8 ways. Then now we start looking at ways when I is 3, I must be less than j plus 2. So we get 3 is less than j plus 2. So 1 is less than j. So j must be greater than equal to 2. So now you realize that j starts from 2 here and can go up to 8, right? So now there are 7 ways, right? And similarly, now if you do I is equal to 4, from this inequality, what will you get? 4 is less than j plus 2. So j is greater than 2. So j is greater than equal to 3. So j starts from 3 to 8. So now you understand the pattern. As I increases, the number of possibilities for j are decreasing. So finally, when I is equal to 9, for example, in that case, j has only one possibility, j can be 8, right? Only one possibility. So you start off with 8 ways when I is 1, then you have 8 ways for I is 2, and then you have 7 plus 6 plus 5 till when I is 9, j has one way, right? So this is the sequence here. When you add it up, you get basically 44. So the number of ways to select ordered pairs for set S2 is 44. And we have basically shown how to do this, right? So that ends our question. We have discussed all the possibilities and we are getting an idea of how to count the cardinalities of all of those sets, right? Let's look at the next problem, question 2. This says, consider a triangle PQR having sides of lengths small p, small q, small r opposite to angles P, Q, R respectively. And we have to choose which options are correct. The first option is cos of P is greater than equal to 1 minus P square by 2PR. The second option is cos of R is greater than equal to Q minus R by P plus Q cos P plus P minus R by P plus Q cos Q. So this is my second option. It is a little complicated looking, but we'll see how to handle it. The third option is Q plus R by P is less than twice of root over sine Q sine R divided by sine of P. Sine of P. And finally, the fourth option is if P is less than Q and P is less than R, then cos of P is cos of Q is greater than P by R, and cos of R is greater than P by Q. So we have to solve this triangle problem, and it has a lot of inequalities. Now let's think about it. Correct. So we'll go by it one option at a time. Okay. And we'll first of all draw a figure. Also, at this point, you should pause the video and try the question yourself. Give yourself 5 minutes, try to attempt this problem and see how many options you are getting, right? So you should try it yourself now, and I will continue with the solution, right? So let's look at the figure here. We have a triangle PQR, and the sides are labeled R, P, and Q, right? Now, in the first option, we had to figure out what was cos of P, an inequality on cos of P. The option was saying cos P is greater than equal to 1 minus P square by 2PR, right? So because they are asking us cos P, we should think of cosine rule. So cosine rule cos P here would be Q square plus R square minus P square by 2QR, right? Now think about it. This can be split like this. Q square plus R square by 2QR minus P square by 2QR, right? This is my cos P. And notice now we can think of this fraction. And since all of the quantities Q and R are positive, Q and R are positive because they are the lengths of sides. So since they are positive quantities, we can apply ANGM inequality, and we can say that Q square plus R square by 2 is greater than equal to root over Q square R square, which is equal to QR. Therefore, Q square plus R square is greater than equal to 2QR. So therefore, we have Q square plus R square by 2QR is greater than equal to 1, right? So we have cos P is equal to Q square plus R square by 2QR minus P square by 2QR. But this is greater than equal to 1 minus P square by 2QR, right? Because we can say that this part is bigger than 1. Therefore, if you replace it with a smaller quantity, obviously cos P is greater than equal to this. So option A is correct for us, right? So we have figured out option A. Now let's look at option B. Option B was looking very complicated. We'll rewrite option B here. Option B was cos R is greater than equal to Q minus R by P plus Q cos P plus P minus R by P plus Q cos Q. So we have to think about how to approach this particular option. So notice that this P plus Q is in the denominator. So we multiply P plus Q on both sides. So we can say the option can reduce to P plus Q cos R is greater than Q minus R cos P plus P minus R cos Q, right? Now, if you think of, correct, we will work with the option itself and see if it comes down to something that is sensible, right? So this is Q cos P minus R cos P plus P cos Q minus R cos Q. And here you have P cos R plus Q cos R, right? So taking this R cos P on the other side, we have P cos R plus R cos P. And we have Q cos R, and we can take this also on the other side. We have plus Q cos R plus R cos Q. is greater than equal to Q cos P plus P cos Q, right? And now this is pretty simple because notice we had a situation like this, PQR, this is R, P, and Q. What is P cos R plus R cos P? P cos R would be the projection of the side QR, and R cos P is the projection of the side PQ. So the sum of those two projections is the side PR. This is the projection rule. So P cos R plus R cos P is equal to Q. Similarly, Q cos R plus R cos Q, Q cos R. So cos R and Q, okay, is again, right. Okay, so this is Q side. And when you do cos R, you will get the projection here. This is the projection of Q cos R, right? And similarly, R cos Q projection is here, right? So the sum of these two is going to be the side small p, right? And similarly here, Q cos P plus Q P cos Q is going to be equal to small r, right? So the inequality in the problem is boiling down to Q plus P is greater than equal to R. But this is actually a statement of the triangle inequality, right? In a triangle, in any triangle, the sum of any two sides is greater than the third side. So this is obviously a true statement. So we have shown that from B, after manipulation, after three-fold steps and using projection rule, we are getting this statement, which is triangle inequality. So obviously B option is also correct. So this is a multi-correct question. B option is turning out to be correct. Now let's look at the C option. The C option was Q plus R by P is less than 2 times root over sine Q sine R by sine of P, right? So let's look at this particular problem now, whether with this inequality is correct or not. Now, if you use sine rule, Q plus R by P can be written as sine of capital Q plus sine of capital R by sine of capital P, right? Why did I use sine rule? Because I have to compare it with something like this and notice that this also has sine Q, sine R and sine P, right? And now we can again basically try to use ANGM here. Why ANGM? Because sine Q and sine R are always positive, because these are angles of a triangle, and angles of a triangle are less than 180 degrees. So obviously sine is positive for all angles less than 180 degrees. So if you use AMGM on these two positive quantities, we can say that this by 2 is greater than equal to root over sine Q sine R, right? So sine Q plus sine R will be greater than equal to twice of root over sine Q sine R and whole divided by sine P. So obviously Q plus R by P is coming greater than equal to this. So option C is incorrect because it says it is less than, right? And finally, we look at option D. Option D was saying that if P is less than Q and Q is less than R, not Q is less than R, P is less than R, then cos of Q is greater than P by R and cos of R is greater than P by Q. This was our option. So let's think about this a little bit. Uh, Correct. So looking at this, what can we conclude from here? Cos of Q is greater than P by R, and P by R is basically sine of P by sine of R using sine rule. So we have sine R cos Q is greater than sine P, right? So, okay, sin r cos q is greater than sin p. So what we can say here is, similarly, we can do this here. Cos r is greater than sin p by sin q, and we can write it as sin q cos r is greater than sin p, right? Correct. So what we are getting, if you add these two results, right? If you add these two results, you're getting sine of q plus r is greater than 2 sine of p. But sine of q plus r is same as sine of p, right? We are getting something like this. Sine of p q plus r is greater than 2 sine p when you add these two inequalities. And now you're getting sine p is greater than 2 sine p, which doesn't make sense, because that implies that minus sine p is greater than 0 or sine p is less than 0, which is impossible, right? Sine p cannot be less than 0 if p is an angle of a triangle. So basically, these two conditions together were giving us these inequalities. And when you combine the inequalities, you are getting a contradiction, right? So D is incorrect. So basically, we have figured out that this option also does not work. And we have the first two options which are correct, right? So A and B will be the answer for this particular problem. Okay. Uh, That's all for this particular video. We saw two problems. One was a counting problem and one was a triangle inequality problem. So hopefully you have learned something from this video. Stay tuned for more JEE advanced practice problems. Please like the video and subscribe to the channel if you're new. Uh, your support helps me make more content. So I would love for you to subscribe and like the videos. See you next time.